So today's topic is going to be the first chapter of physics, electric charges and fields. Electric charges include positive and negative charges, like charges and unlike charges. Like charges repel, like positive and positive repel, negative and negative repel. Unlike charges attract each other, like positive and negative. Conductors and insulators. Conductors allow movement of electric charge through them, while insulators do not. Conductors allow electric charge to pass through them because they are mostly made of metals, and metals have a free electron, more than one free electron in their configuration, which allows the electric charge to be conducted. Insulators are electron deficient and hence do not have enough electrons to transfer the charge from one place to another. Quantization of electric charge. It means the total charge Q of a body is always an integral multiple of a basic quantum of charge E. Total charge includes the charge of all electrons of a body, which is Q equals to Ne. The charge of a single electron is 1.6 into 10 to the power minus 19. Therefore, a body containing 10 electrons will have a total charge of 16 into 10 to the power minus 19 coulomb. Q equals to Ne, where N equals to 0, 1, plus minus 1, plus minus 2, plus minus 3. Additivity of electric charges. Total charge of a system is the algebraic sum of all individual charges in the system. Total charge is different from quantization of electric charge, since total charge is bigger than quantization and it includes all those smaller charges that quantization makes up. It is the algebraic sum of all individual charges and not the charges that are together and attract each other. Conservation of electric charges. The total charge of an isolated system remains uncharged with time. Since there is no external force to attract or repel the charges, it stays unchanged in an isolated system. An isolated system is a system where there is no change of energy or mass, basically like by vacuum in space. Superposition principle. It is the properties of forces with which two charges attract or repel each other and are not affected by the presence of a third or more additional charge. Two charges also means dipole. It is a property of forces, of external and internal forces, which the two charges attract and repel, and they are not affected by a third or more charge since they are in a superposition. The electric field E at a point due to a charge configuration. It is the force on a small positive test charge Q placed at the point divided by a magnitude modulus Q upon 4 pi epsilon naught r square. Modulus Q is the total charge which has to be positive. 4 pi epsilon naught is the constant K which has a value of 9 into 10 to the power 9. R is the distance. Therefore, electric field at a point is modulus Q upon 4 pi epsilon naught distance square. It is radially outwards from Q if Q is positive and radially inwards if Q is negative. According to the graph, the line is radially inwards towards 0, that is if Q is positive, and radially inward if Q is negative. E at a point, capital E at a point varies inversely as the square of its distance from Q. The plot of E versus R will look like the figure given below. Coulomb's law: the mutual electrostatic force between 2 point charges Q1 and Q2 is proportional to the product Q1 and Q2 and inversely proportional to the square of the distance R21 separating them. Vector F21 force on Q2 due to Q1 is given by constant K Q1 Q2 upon R21 square with the vector of R21. Coulomb's law basically is that mutual electrostatic force between two charges, and it is also proportional to the product of Q1 Q2. It is also inversely proportional to the square of the distance of R21 separating them, where vector R21 is a unit vector in the direction from Q1 to Q2 and K is 1 by 4 pi epsilon naught, which is a proportionality constant, and the value is 9 into 10 to the power 9. An electric field line. It is a curve drawn in such a way that the tangent at each point of the curve goes to the direction of the electric field at that point. An electric field line is caused by a dipole which includes a positive and a negative charge. The electric field line travels from positive to negative. The positive charge releases the field lines, while the negative charge accepts the field line, which causes a continuous loop of an electromagnetic field. Important properties of field lines are: the field lines are continuous curves without any breaks. Field lines go from positive to negative. There cannot be field lines cannot intersect, as it would mean that the place where they are intersecting has two poles, which is not possible in a dipole.